Hello and welcome to lesson 4 on differentiation. Subtopic is equation of a tangent and a normal to a curve. So we start by defining what is a tangent and what is a normal. So we can write this one, that tangent. So a tangent is a line that touches the curve at only one point. A tangent is a line that touches the curve at only one point, i.e., so I'll have a sketch. If this is my sketch, then there is a point here. Then there's a line passing through that point. So this one becomes my curve, and this one is the tangent. Now, what is a normal? A normal to a curve is a straight line that is perpendicular to a tangent at a point, i.e., if this one is my curve, then we have a line that is touching the curve at a particular point. So let's say this is the point. Then a normal is the line that is perpendicular to that tangent. So this one is now my curve, this is the tangent, and this one here is the normal. Examples: find the equation of the tangent to the curve y is equals to x squared plus 2x plus 1 at point 1, 2. So if I was to sketch this one, I've been given a curve, then there is this point 1, 2, there is a tangent that is passing through that point. So I can use the gradient of this curve at this point. The gradient of this curve at this point is the same as the gradient of this tangent. So if I know the gradient of a line, then I can easily get the equation of that line. So to get the gradient at this point, we differentiate this one and get the gradient function. So we say our dy dx will be, so we differentiate this one. So we say this is 2, you multiply by whatever is in front of x, that is 1. So this will be 2, then you minus 1 from that power, so it will be 2x plus, so this is the same as x raised to 1, so 1 times 2, it is 2, then you minus 1, it will be 0, so x raised to 0 is 1. So if you differentiate a constant, is 0. So this one becomes my gradient function. So therefore, at x is equals to 1, because this is the point, the value of x is 1, what will be the gradient? Our dy dx will be 2, 1 plus 2. So therefore, this will be 4. So our gradient is 4. This gradient of this curve at this point is the same as the gradient of this tangent. So we said, for you to get the equation of a line, you need 3 things. You need the gradient, which we have is 4. We need a point that is passing through that line. Here we have 1, 2. Then we need arbitrary point xy. So we have the three things that we need, and we know gradient is change in y over change in x. So our gradient here is 4. You can say it is 4 over 1 is equals to change in y. We start with this one, so y minus 2 over x minus 1, like that. So therefore, if you cross multiply this one, so this one will be y minus 2 is equals to 4 into x minus 1. So you can simplify this one as y minus 2 is equals to, open the bracket, this will be 4x minus 4. Take to the other side, you'll have y is equals to 4x minus 4 plus 2. So finally, my y will be equals to 4x minus 2. Example 2. Find the equation of the tangent to the curve y is equals to x raised to 3 plus x squared plus 1 at 1, 3. So if we sketch that one, so let me assume this is my curve and this is our point. So I have a line that is passing through that point, which is our tangent, and the point is 1, 3. So I can now get the gradient of this curve at this specific point by differentiating this function. So I will say this is dy dx is equals to, so this will be 3 times 1 is 3 x 2, so we minus 1 from that power, plus you drop this 2 down there, this will be 2 x minus 1. So 2 minus 1 is x raised to 1. So if you differentiate a constant, it's 0. So this becomes our gradient function. So at x is equals to 1, because this curve is passing through this point, so and here x is 1. So we substitute x in this function to get the gradient. So we'll say our dy dx will be equals to 3 1 squared plus 2 1. So this one will give you, this is 1, so 3 times 1 is 1 plus 2 times 1 is 2, so 3 plus 2 is 5. So our gradient is 5. So we are saying if this is the gradient of the curve at this point, this gradient is the same as the gradient of the line, which is the tangent. So we have the gradient of that tangent, which is 5. Then we have a point that is passing on that line, which is 0.13. Then we have arbitrary point xy. So these are the three things that we need to get the equation of a line. So we're going to say gradient is change in y over change in x. So our gradient is 5, so we'll have 5 over 1 is equals to change in y. So it is y minus 3 over x minus 1. So you simplify this one by cross multiplying this one. So you'll have y minus 3 is equals to 5 into x minus 1. So if you open the bracket, you will have y minus 3 is equals to 5x minus 5. So take this 3 the other side, y will be equals to 5x minus 5 plus 3. So you're going to have y is equals to 5x minus 2. Find the equation of the normal to the curve y is equals to x squared plus 2x plus 1 at the point 1, 2. So again, now this time round you're being told to find the equation of a normal. So from my sketch, so I'm saying this is my curve, so I'm having a line that is touching that curve at that particular point. Then a normal is the line that is perpendicular to that tangent. So I'm being told to find this equation of that line. So the point here is 1, 2. So we can find the gradient at that particular point of that curve. So we can say dy dx is equals to, so we differentiate this one, so that will be 2x plus 2, because this one is, you drop here 2u minus 1 will be 2x. This is like x raised to 1, so you multiply by 2, u minus 1 will be x raised to 0, which is x raised to 0 is 1, 1 times 2 is 2. So this is our gradient function. So therefore at x is equals to 1, then our dy dx will be, so 2, 1 plus 2, so it is 4. This is the gradient of the curve at this point, and it is also the gradient of the tangent. So we can say this is our m1 and this is our m2. So using the concept of perpendicular lines, if I take m1, I multiply by m2, is supposed to give me -1. Then we have what is m1. m1 is 4. I multiply by m2, supposed to get -1. So divide by 4 both sides. So my m2 will be -1 over 4. That is the gradient of the normal. So I said that if you want to get equation of a line, you need 3 things: the gradient, you need a point that is passing on that line. So still this 1, 2 is still on that line, so it will be 1, 2. Then you need arbitrary point xy. So those 3 are enough. So we're now going to say gradient is change in y over change in x. So this time our gradient is -1 over 4 is equals to, so we start with y, so it will be y minus 2 over x minus 1. So cross multiply this one, so this one will be 4 into y minus 2 is equals to -1 into x minus 1. So we open the bracket, this will be 4y minus 8 is equals to minus x plus 1. So this one can be simplified further as 4y is equals to -x plus 1 plus 8. So this will be 4y is equals to -x plus 9. So you can leave the answer at that point, or you can divide both sides by 4, everything by 4, so that you have y is equals to -1 over 4x plus 9 over 4. Find the equation of the normal to the curve y is equals to x cubed plus x squared plus 1 at 1, 3. So again, if we are to sketch, so we assume this is our curve, and then there is this tangent, and then there's a normal, the line which is perpendicular to that tangent. So the question is asking us to get the equation of this normal. So the point here is 1, 3. We find the gradient of the curve at that particular point. So we differentiate this function. So this will be dy dx is equals to, so 3 multiplied by 1, this will be 3x squared. We subtract 1 from that power, plus this will be 2x. So you multiply by 1, 2, then you subtract 1. So this one becomes your gradient function. Then at x is equals to 1, because this is the point, the value of x is 1, our dy dx will be 3, 1 squared plus 2, 1. So if you simplify this one will give you 5. That is the gradient of the curve at this particular point. This gradient is the same as the gradient of the tangent. So we can say this is our m1 and this is our m2. So we always say 1 is 5 multiplied by m2 should give me -1. So divide by 5, divide by 5. So my m2 will be -1 over 5. So we have the gradient of the normal. We need a point that is passing through that line, which is -1, 3. Then you take arbitrary point xy. So these 3 can help us get the equation of the normal. So we say gradient which is gradient is change in y over change in x. So our gradient is -1/5 is equals to, so we start with this one, y minus 3 over x minus 1. So if you simplify this one, we'll have 5 into y minus 3 is equals to, you multiply by -1 into x minus 1. So if you open the bracket, this will be 5y minus 15 is equals to -x plus 1. So you can simplify this one as 5y is equals to -16 plus 1 plus 15. You take this 15, the other side will be positive. So we'll have 5y is equals to -x plus 16. You can leave your answer at this point, or you can divide everything by 5 so that you have y is equals to -1/5x plus 16/5. And that is how you get the equation of a tangent and a normal to a curve. Thank you so much. Lesson 5, loading.